correlation. We already done the Carl Pearson's coefficient of correlation. In the next, we will study the some assumptions underlying the Carl Pearson coefficient. So, what are the various assumptions? So, the variables x and y under study are linearly related. So, first assumption is that all the data of x and y, there is a linear relationship between the both the variables. So, first assumption is that, and second is each of the variable series is being affected by a large number of independent contributory causes of such a nature as the produce the normal distribution. So some are the factors, or we can say external factors, which may be affect the normal distribution of data. So maybe the data may be affected by the large number of the extraneous variables, or the variables which are affected, or we can say the independent variables apart from the variable we are considered for our study. So maybe there are some other data or other independent variable which are not the part of the study, but they can directly and indirectly affect the our distribution or our study or our research study. The forces so operating and each of the variable series are not independent of each other, but are related in the causal fashion. So the variables are not dependent on each other. So x or y, maybe some of the forces, or we can say the operating forces, not depend on the variable series. All the data not depend on each other. All the values, for example, there is x values of 2, 3, 4, 5. Maybe this is not depend on this. This may not depend on this. So, but there may be also be. It says that each other, but are related to in the causal fashion. But they are interrelated to each other in the cause and effect relationship. Causal fashion means there is a cause and effect relationship. Cause and effect relationship. So sometimes the data may be depend to each other. Why? X or Y may not be depend to each other, but it may be some cause and effect relationship between the both the variables. Now there are some properties of the coefficient of correlation. For property 1, limits for correlation coefficient, it can be used only for the coefficient of correlation, calculation of the coefficient of correlation. So correlation coefficient is independent of the change of the origin and scale. So when we will change the origin as well as scale, if your origin means if you will add the same value in the all the plus 1, plus 1, plus 1, plus 1, same as y, you are adding the some another value plus 2, plus 2, plus 2. So whenever you will change the values in that, it also change the origin. It also change the value of r. And the scale, if you are changing the scale, means when you divide the value for the same number. For example, I divide the all the value by the 2, by 2, by 2, 7, 8, 9, like that. So if you divide by 3, by 3, by 3, by 3. So when you are divide the or multiply, or you are multiplying the same value with the same amount, then it also changes the correlation values. It also change the correlation value. So that's why it's called that it depend on the change of origin. Origin means adding or subtracting the some amount in the value. Scale means multiplying or dividing the all the series, all the observation with the same number. So it also affects the correlation coefficient. The third property is that the two independent variables are uncorrelated, but the converse is not true. Two independent variables are uncorrelated. दो independent variables हैं वो uncorrelate हो सकते हैं, but the converse is not true. Uncorrelated independent variables, uncorrelation may not be independent, but independent variables are uncorrelated. कोई भी independent variable है, for example, we have taken the independent variable like the soil quality, rain water, quality of seeds. So for example, these are the independent variables, and dependent variables is the crops production. crops production. So it's saying that the two independent variables, these two independent variables are uncorrelated. But the converse is not true, means uncorrelated. Sometimes the uncorrelated variables may be independent. Okay, may be dependent. So these all may be dependent to each other. If the rainwater will be good, then the soil quality will also for the quality of seeds. The quality of seed will work only when there will be a proper soil quality and the rainwater. So the quality of soil is correlated to the and depend on the soil quality and the rainwater. So quality of seeds depend. Without the all these variables, the quality of seed cannot be performed well. So it may be correlated, it may be depend to each other, but two independent variables are uncorrelated. हो सकता है uncorrelated हो, but vice versa is not true. Property 4. It's saying if you are multiplying and dividing the value with the same amount, it will also change the value of R. If you are multiplying, you are adding the values in that, and you are multiplying the values with the same amount, it also change the value of R. Property 5th है, if the variables x and y are connected by the linear equation, this is the linear equation, then the correlation coefficient between x and y is +1. अगर लीनियर कोरिलेशन है तो उसके बीच में कोफिशिएंट है +1 ही होगा. इफ द साइन ऑफ ए एंड बी आर डिफरेंट एंड -1 इफ द साइंस ऑफ ए बी आर अलाइक. सो अगर आपका जो वेरिएबल्स है एक्स एंड वाई अगर लीनियर इक्वेशन या लीनियरली इंटरलेटेड है. लीनियर मीन्स इफ 1% चेंज इन द एक्स द सेम प्रोपोर्शन विल बी चेंज इन द वाई like that. So this provide a linear line. So if the variables x and y are connected by the linear equation ax plus by plus c is equal to 0, then the correlation coefficient between x and y, then the correlation coefficient between x, y, the r will be the +1. If the sign of a and b are, अगर इनका साइन है a और b का साइन are different, अगर डिफरेंट है -1 if the signs of a and b are alike. So अगर माइनस इनका साइन माइनस में है तो हमारा कोरिलेशन भी माइनस में आएगा. अगर साइन ए और बी के जो साइन है हमारे प्लस में है तो हमारा कोरिलेशन भी प्लस में आएगा. ठीक है, इट विल ऑल्सो बी इन द प्लस पॉजिटिव. नाउ दिस इज द one more example is given how you can solve the coefficient of correlation. So the age group, this is given the 15 and less than 20, 20 and less than 25. So which type of the series is that? It is a continuous series. Okay, so now number of people is given and number of players. So there are two things are given. So the one value is given the x. So how you can calculate the another value of y? So find the calculation coefficient of correlation between the age and the playing habits. तो playing habits पूछ रखा है इन्होंने कि playing habits of the people from the following information. Also mention what does you calculate R indicate. So first of all we have to define the interval class. After that number of person is given 200, 270, 340 and number of players. So we have to calculate the proportion कि how much percentage of player out of that. So how you can calculate 150 divided by 200 multiplied by 100 75, 162 divided by 270 multiplied by 100 60. So you can calculate and it will be the value of y. So y हम यहाँ से calculate कर सकते हैं, निकाल सकते हैं. ठीक है, तो x y हमने निकाल लिया था वहाँ से कैलकुलेट. x कैसे निकालेंगे? द मिड वैल्यू ऑफ ईच एंड एवरी वैल्यूज. सो 50 plus 20 divided by 2, so it will be mid value of 17.5, 22.5, 27. After that you can also calculate the dx. Instead of you can mention the dx, which I already tell you in the previous example. dy and dx square you can denote it dy square and dx into dy. Same formula we can use, and the formula we will use like that, and summation dx dy minus summation dx into summation dy by n into summation dx square minus summation dx का whole square and the factor of y multiply by summation dy का dy square minus summation dy का whole square. So you can calculate this formula and put all the values here, and you will find the value is the minus. It is negative highly, or we can say high degree of negative correlation. So the high degree of 0.93. It lies in the high degree of negative correlation between the both x and y. Now what is the probable error? You can solve the probable error. The formula of probable error is 0.6745 multiply 1 minus r square and divided by under root n. So 1 minus r we already calculated correlation and number of observation is there. So you can calculate the probable error by using this formula. So usage of probable error. What is the usage? The probable error of correlation coefficient may be used to determine the limits within which the population correlation coefficient may be expected. So it provides a limit in which the coefficient of correlation will lie. So that a limit in which, like that, what is the maximum limit, what is the minimum limit. So the values of r or the correlation coefficient may be used to determine the limits within which the population correlation coefficient may be, where the population of correlation of coefficient of the population will be lie. So probable error may be used to test if an observed value of a sample correlation coefficient is significant of any correlation in the population. So it also provide and also used to test whether the coefficient of correlation is as per according to population correlation or not, whether the sample correlation coefficient will be significant with the population coefficient of correlation. Okay. So it provides a significant or hypothesis testing. Now the next is the rank correlation method. Spearman rank coefficient coefficient of correlation. Spearman rank correlation coefficient. So in that, sometimes we come across the statistical series in which the variables under the consideration are not capable of qualitative measurement. So it is used for the qualitative measurement, and Karl Pearson coefficient of correlation will used for to analyze the quantitative data, and it deals with the qualitative information. So rank correlation will be used for the qualitative, and the Karl Pearson coefficient, it deals with the quantitative measurement, but can be arranged in the serial order. So this happens when they are dealing with the qualitative characteristics attributes such as the honesty. We want to study the honesty, beauty, character, morality, which cannot be measured quantitatively but can be arranged serially. So Charles Edwin Spearman, who founded the formula rank correlation coefficient, a British psychologist, developed a formula in 1904 which consists in obtaining the correlation coefficient between the ranks of n individuals in the two attributes under the study. So he taken the two attributes under the study. So the Pearsonian correlation coefficient between rank x and y is called the rank correlation coefficient between the characteristics of A and B for that group of individuals. So superior rank correlation coefficient usually denoted by the रो से हम इसको डिनोट करते हैं. You will use the rho like that. So it will be 1 minus 6 into summation d square divided by n into n square minus n, or you can also write the n cube minus n. So d means the deviation between both the ranks, rank 1 minus rank 2. So d means deviation. So how you can compute that? There is a two case in which we can compute the rank correlation coefficient. First is the when actual ranks are given, and another is when ranks are not given. So the first case, when the actual ranks are given, then how you can calculate? So this is the example where the ranks is already given. So first case is the when ranks are given. When ranks are given. So when ranks are given, then how we can calculate? First of all, we have to take the deviation between R1 and R2. X or Y means R1 rank 1 minus rank 2. You have to calculate the deviation. 1 minus 10 minus 9, 2 minus 7 minus 5, 3 minus 2 1, 4 minus 6 minus 2, 5 minus 4 1, 6 minus 8 minus 2, 7 minus 3 4, like that. After that we need the d square, so we have to square all the value. 9 square 28, 5 square 25, like that. Then we have to make the total summation d square 272, and we have to put the value 1 minus 6 summation d square value is the 272, and is the 15. Total number of observation is the 15. Total number of observation कितनी है हमारी? n कितना है? 15. So 15 into 15 square 225 minus 1, then it will be 0. So it shows the moderate degree of positive correlation between the both the ranks. So this is the case when the ranks are given, and the second when ranks are not given. So you have to give the highest observation is given the rank 1, then the next highest value, or you can just give the rank from the descending order. You can also give the rank in the ascending order. It's depend on you how you can give the ranks. So here you can see the calculate the Spearman rank correlation test between the advertisement cost. It's not given the rank. It's not the rank. It's the value of X, and the sales value of Y. It's not the rank. So we have to assign the rank. So both the data of X and Y is given. So we have to assign the rank. So this is the value. So in this case we have to assign from the smallest one. We have to give the 1 value, then the 2 and the 3. So in this case they have to assign the highest as the first value. So 98 we have to assign the rank 1. After the 98 after the 90 we assign the rank 2. After 90 90 के बाद 82 we have assigned the rank 3. After that 82, then 78 we have assigned the rank 4. Then 75 rank 5. Then next is the 76. After that 65 we have assigned the rank 6. Next rank is 62, assign the rank 7. After that 39 the 8th rank. After that 36 9th rank, and 25 10th rank. So same in this we can also assign the rank. So highest one is this in this Y. Highest one is 91, the rank 1. Then 86, assign the rank 2. After that 84, third rank we have to assign. Then after that 68, the 4th rank we have assigned. Then 62, the 5th rank. Then 60, 6th rank. Then 58, 7th rank. Then 53, then 8th rank. Then 51, 9th rank. Then 47, 10th rank. So rank, we already get the rank. So after that rank, the next procedure will be same which we have already done in the previous exams. So here you can also write the R minus R2, rank 1, rank 2. 8 minus 10 minus 2, 6 minus 8 minus 2, 7 minus 7 0, 2 minus 2 0, 3 minus 5, like that. After that we will square all the values. 2 square 4, 2 square 4, and we have to total 30. The same formula we can use. 6 1 minus 6 into summation d square 30 divided by n. N is the 10 multiplied by 10 square 100 minus 1 99. So it will be, and it shows the high degree of positive correlation. It shows the high degree of positive correlation. So this is the case when ranks are not given. When ranks are not given. When ranks are not given. And the third situation is that when there is equal or tied ranks. अगर equal ranks आ जाए, हमारे पास tied rank आ जाए, तो how you can calculate the rank correlation? So for the equal and tied rank, I will just tell you how you can calculate. So in the equal or tied rank, we have to use the formula. Which formula you can use? 1 minus summation d square plus 1 divided by 12 m3 minus m plus 1 divided by 12 m3 minus m. M means the repetition of rank, the rank which is repeating, and so on. Okay. So this formula we can use when there is a equal rank or tied rank, and n square minus 1. So for example, I am taking a example. Value of x is given and the value of y is given. So we are taking the example like that: 3 4 7 9 3 8 2 4 3 2 7 5 4 2 4 2 1 8 2 and 6. So first of all, we have to assign the rank R1. So see it carefully and listen carefully. And R2. So how we can calculate the values in case of the equal rank? So you can say that this equal value is given here, the 3 3 and 3. Now you can also take 4 and the 4. Here the 2 2 2, they are repeating, or the equal rank. So first of all, we have to give the rank, assign the rank. So from highest to smallest we can assign. So in that, which is the highest one? 9. 9 with the highest one, we have to assign the rank 1 to 9. After 9, the 8 is the highest rank. 2. After the 8, there is the 7 is the third rank. And then after the 7, four is repeating 2 times. That means 4th and 5th position, we have to fill the 4th and 5th position. So first rank we assign, the second rank we assign, and third rank we have assigned. Okay. So now we have to assign the 4th and 5th rank, but on the 4th and 5th rank the value is the same. So how we can do? We have to take the average of the 4th and 5th position. 4th plus 5th position divided by 2. It will be 9 divided by 2 means 4.5. So for both the rank, for 4th and 5th position, we have to assign 4.5 to 4th position and 4.5 to 5th position. So up to 5 position is filled. Now the 6th rank. So we have to give 3 as a 3 Next is the 3. 3 is repeating 3 times. Means the 6th position 3 times repeated, 6th, 7th and plus 8th position. On all the 3 positions the value is 3. So we have to be average of all the 3 positions. The average will be 3. So 7 we have to be assigned the 7 for the 6th rank, 7th rank and the 8th rank. So for 6th rank we assign the 7. For 7th rank we assign the 7. And for 8th rank we assign the 7. Then 9th rank. The 2 is remaining, so we have to give the 2 as the 9th rank. Okay. So we have to assign the 9th rank. Then in this you can see the highest one is the 8. We have to give the assign the value 1. After the 8th, 7th, 2nd rank, then 6th and 3rd rank, 6th, 3rd rank. After the 6, 5, 4th rank, 4th, 5 rank, 4 के बाद 2. So 2 is repeating 1, 2, 3 times. It means 6th position plus 7th position plus 8th position. So all 3 positions we have to assign with the average value, average rank. So it will be 7. So we have to assign the 6th position, 7th position and 8th position with 7th rank. 7th rank and 2 is a 7th rank and the 7th rank. Then after that the 1 we have to assign the 1 as the 9th rank. So all ranks we have to given the calculated. Then after that we have to calculate the D means R1 minus R2. Then D square. So 7 minus 7 0, 4.5 minus 2, 2.5. 3 minus 4 minus 1, 1 minus 5 minus 4, 7 minus 7 0, 2 minus 9 minus 7, 9 minus 1 8, 4 minus 5 4.5 minus 7. So it will be 3 point minus 3.5 then 4. So after the taking the deviation you can square all the values. You can square all the values. Okay, sorry. 4.5 minus, it will be 2.5 minus 2.5. Okay, then you have to make the total of that. No, first of all you have to be square the values. 0 square 0 and 2.5 square 6.25, 1 square 1, 4 square 16, 0 square 0, minus 7 square 49 and 8 square 64 and minus 2.5 square is the 6.25 and 4 square 16. So after that you have to make the total of all the values. 6.25 plus 1 plus 16 plus 49 plus 64 plus 6.25 plus 16, so it will be summation d square, the value will be 158.5. okay, then you have to put the values in the formula. You have to put the values in the formula. So first of all we have to be see ki how many times which value is they are repeating the maximum times. So you can see the value is repeating. First value is 3 repeating the 3 times, and then 2 repeating, now 4 repeating 2 times. So first of all 1 minus, you have to put the value 1 minus 6 summation d square. Summation d square value is 158.5 plus 1 divided by 12. So first value is repeating 3 times, the 4 is repeating, 3 is repeating, 3 cube minus 3. Now the next value is repeating 4 repeating 2 times, so m value will be 2. Now the next is repeating the 2 is repeating 3 times, so m will be so m equal to, m is the values which are repeating, how many times the value is repeating. So next is the 2. In the y you can see the 2 is repeating 3 times, so m is equal to 3 cube minus 3, and divide by n cube minus n, or you can say the n into n minus 1. So n value is the total number of observation 9, then 9 square minus 1. So you can solve it. 1 minus 6 multiplied by 158.5 951, it will be 951 plus 1 divided by 12 into 3 ka cube, 3 cubes 27 or minus 3, it will be 24. So 24 divided by 12, so it will be 2 plus next 1 divided by 12, 2 square, 2 cube, 8 minus 2, 8 minus 2 6, 6 divided by 12 0.5, and again it will be 24 divided by 12, it will be 2, and divide by